Now, acceleration. Acceleration is none other than the change in velocity per second. So, for example, if you were traveling with 500 kilometers per hour at 0 seconds at time 0 seconds, and with 750 kilometers per hour at time 5 seconds. So acceleration is your change in velocity with respect to time. So you are moving forward in time and you're also changing your velocity. So let me clear one important thing. Positive acceleration can also happen and negative acceleration can also happen. As you might start from 500 but end up after 5 seconds with a speed of 250. So, excuse me, with a speed of 250 kilometers per hour. See, so there are two aspects of it where it can also be positive acceleration and it can also be negative acceleration. In positive acceleration, an object increases velocity over time. But in negative acceleration, the object, its velocity decreases over time, and we call this term as deceleration. Friends, deceleration or deceleration is a simple term when we have negative acceleration. Now, the formula for acceleration in your books, it might be given change in velocity upon change in time. Okay, this is the symbol delta which shows change. So let's assume that here v is the final velocity, u is the initial velocity, okay, and t is the time as usual. So first of all, by solving the question which we created ourselves, so the v is 750, as you can see here, 750 kilometers per hour. Be very specific with the units. 750 kilometers per hour at time 5 seconds. So we can simplifying this, what do we say, different, matlab, a formula which is quite complicated and making it easy, we can write it as v minus u upon t2 minus t1, t2 minus t1. So v is 750 and 750 and u is 500, so we'll subtract 500 from it and then divide it by time. Change in time is 5 minus 0, that is 5, so we get 250 by 5, and so our acceleration would be 50 kilometers per hour square. Now let me tell you why would it be 50 kilometers per hour square. And let me I'll just remind myself. I'll also be teaching you how do we convert kilometers per hour to meters per second, as there are a few tricky questions where you are given a few quantities in kilometers and others in second, and then they ask you to give the answer in meters per second, which is the standard unit. So the standard unit for acceleration is meters per second square. So change in velocity. So what would happen is that meters per second is the unit. So meters per second here and meters per second there. They would be subtracted and we would get meters per second by time. And that second would get multiplied. This is a bit unclear for now, but I'll just explain it to you. Just a second. So acceleration is change in velocity. So that becomes meters per second minus meters per second upon time. So time itself is its standard unit is second. So meters per second upon second. So what do we get here? It's something like this: meters divided by second into second. So we'll get meters per second square. So this is how we get this standard unit for acceleration. Well, it's not a standard unit, it's a derived unit. As you can see here, we did derive it, but it's for well, the main unit for acceleration is meters per second square. Now moving forward, friends, I hope you understood what positive acceleration is, what negative acceleration is. Acceleration in simple terms is change in velocity per unit time, that is per second. So change in velocity at x time, if the body had 500 meters per second speed, and at x plus 5 fifth x plus 5 time we have 750 meters per second. So the velocity, change in velocity with respect to time, which would give us acceleration, would be 250 meters per second upon uh, x, 5 would be left as x minus x plus 5. So xx would cancel and we would have 5 seconds. So imagining x also equals to 0, so we'll have that answer 250 divided by 5, which would give us 50 meters per second square. I hope you've understood the topic.
Bye bye, subscribe to my channel and keep learning.